Okay guys, today we are going to be evaluating sinusoidal functions. So we've already graphed these, and we looked at the inverses of them, so now what we're going to do is we're going to evaluate them at certain points. And the first one we're going to start with is this part A, that is f of 8. Okay, so we're going to look at that first given function. We want to evaluate f of 8, which if you guys look, originally it says f of x is equal to that function. That 8 has just taken the place of that x, so all we're going to do is everywhere there's an x in that function, we're going to replace it with an 8. So I have 2 plus 3 cosine pi over 9 times x minus 6. And that x is getting replaced with 8. So now you are going to be able to use a calculator for this entire unit because some of these are a little bit too complicated to do without a calculator. So the hardest part about this part is just making sure we put our parentheses correct on here. So one thing you have to realize is when I put my parentheses in this function, I am taking the cosine of all of this. So I have to make sure that I don't close my parentheses too soon. And we're going to see what that looks like on the calculator just to make sure we have it right. So I'm going to show you guys. Here's my calculator. And I'm going to move this over so I can see my function. So it's 2 plus 3 cosine pi over 9. And then this is the place I need to be careful. I need to make sure I do not close my parentheses yet, because I'm also taking the cosine of 8 minus 6, or 2 if you want to just type that in. So this is the entire function I'm typing in to evaluate my function at 8. Now I want to make sure I double check my mode. My mode is in radians, which is what I need, so that's good. So once I have that typed in, all I need to do is press enter and I get my answer. In general, make sure you read your rounding directions, but a lot of times we're going to round these to 3 places past the decimal. So this would be rounded to 4.298. All right. Now for the next part, we're going to use a calculator again. However, we're going to have to show a lot of the algebra in order to get to that point. Okay, so this is going to be very algebra intensive. So to start off, this says that f of x is equal to 1.3. So what that means is f of x is going to get replaced with 1.3. So the entire left side of my equation is getting replaced with 1.3. And now I just need to solve for x to get it by itself. So I'm going to start with, what I would normally do to solve an algebraic equation. The first thing I'm going to do here is I'm going to subtract 2. Because you have to remember, all of that is all multiplied together. So I can't really mess with anything that's there yet. So first thing I'm going to do is minus 2. And I get a negative 0.7. And now I'm here. So my next step, what I want to do in order to get x by itself, I need to get this entire cosine function by itself. So what that means I need to do is I need to divide everything by 3. Now I'm going to leave this, in order to get a really exact answer, I'm going to leave it as negative 0.7 over 3, just for right now, because we are going to use a calculator for this. Okay, now the next step is the complicated part, okay? So in order to get that x by itself, if you guys remember back in our last unit when we talked about inverses, if I had y equals this, actually let me write it this way. In our last unit when we had x equals the sine of y, the only way we were able to get that y by itself, the only way to take it out of that sign was to rewrite it as an inverse. So what we're going to have to do here, the only way we're going to be able to get this pi over 9 x minus 6, the only way to get all of that by itself is to rewrite this function as an inverse. So what I'm going to do here is I'm going to rewrite this. I'm going to not change anything, I'm just going to rewrite it a different way, and I'm going to rewrite this as cosine inverse of that left side, so of negative 0.7 over 3, is equal to pi over 9 times x minus 6. So all I did was, again, I rewrote this as an inverse. And now I'm going to continue to solve this, and this is where I need to use my calculator, because I can't evaluate cosine inverse of negative 0.7 over 3 without one. So I'm going to go to my calculator, I'm going to type that in. And when I type that in my calculator, I get a value of 1.806, and that's the principal value. Now, this is the other tough part. Whenever I type this into calculator, the calculator only gives me the principal value. However, I'm trying to find my general solution in this case, or many of the answers that are going to be possible. So I need to find the other places where this is true. So what I'm going to do here is I'm going to rewrite this a little smaller. So generally, this is 1.806 plus 2 pi n, and that's going to equal my pi over 9, x minus 6. Now the other part that I have to worry about here, though, is the second solution that I would get. Now if we think about this again, cosine was negative, okay? So cosine is negative in the second quadrant. That's the principal quadrant. So the answer that my calculator gave me was this second quadrant answer. Okay, so that was 1.806 radians. And if you think about it, that makes sense because this is 3.14 radians. That's pi radians. And then pi over 2 radians, that's 1.57 radians. So what I need to figure out is the equivalent value in the third quadrant. Okay, so there's a couple ways you could do this. You could go and you could find the reference angle and do a little bit of work, or you can just think about this the simple way. If I'm using a cosine function, okay, cosine, this just gave me that value right there is 1.806 radians. I need an equivalent reference angle in the third quadrant. So that means that this reference angle is the same in both places. So if going in the positive direction, it's 1.806 radians, an equivalent fourth quadrant value would simply just be going in the negative direction. So I can rewrite the second half of this solution as simply negative 1.806. And I'm a little bit out of space, but other than that's going to look the same. Okay, so I'm going to continue to solve the left side now. Okay, so I look at this left side. My next step here, again, normal solving equations. In order to get this x by itself, I need to multiply by pi over 9. Sorry, I need to multiply by 9 over pi. So I'm going to take everything here, and I'm going to multiply it by 9 over pi. So that means I'm going to multiply my left by 9 over pi. And I'm going to get 5.174. And I'm also going to multiply that plus 2 pi n. So when I multiply plus 2 pi n times 9 over pi, those pi's will cancel out, and I'll just be left with 18n. And now this equals x minus 6, because if I multiply this by 9 over pi, those would cancel out. And at this point, it's really simple. My last step is just simply going to be to add 6. And if you remember like terms, I can't add 6 to 18n. I can only add 6 to that 5.174. So this becomes 11.174 plus 18n. So this is the first part of my general solution. Okay, now I'm going to make a little bit more space. I'm going to rework the second half of this. All right, so the second half was that second solution. And that's honestly, that is the hardest part of this probably, is going to be to find where that second half of that solution is. So I have negative 1.806 plus 2 pi n equals pi over 9 times x minus 6. I'm going to work this out the same way. I'm going to multiply both sides by 9 over pi. So I'm going to do negative 1.806 times 9 over pi, and it's going to give me the same value but negative. So I have a negative 5.174 plus 18n. and that equals x minus 6. So again, my last step is going to be to add 6. So I'm going to add 6 to both sides, and I'm left with x equals 0.826 plus 18n. So this, let me go ahead and circle the whole thing together. This is my general solution here. So it is some complicated algebra, but again, if you go step by step, it is just algebra. The hardest part here is going to be to find this second solution. And we're going to do another example in a second to hopefully help us figure that out. Now, if I wanted to find my first 3 positive x values, I can still do that. Again, I use my general solution. Of that general solution, the smallest number, that's 0.826, so that's my first one. My second one is 11.174, and then my third one would be my smallest number plus that interval, and that interval is 18, so it would be 18.826. Okay, we're going to work one more, and we're going to do this one as this one is a sine function, but we're going to work it the same way. Okay, so what we're going to do here is we're going to start off the same way. I need to figure out how to write this equation. F of x is equal to 6. So f of x is the same thing as y, so that 6 is going to replace my y. So the equation I'm trying to solve here is 6 equals 4 plus 3 sine pi over 6 x minus 2. All right, now I'm going to try to solve this. First thing I'm going to do is just minus 4. And then the next step here, I'm going to divide everything by 3. And now I'm going to rewrite this as an inverse. Okay, so I'm just going to rewrite this. And again, I'm going to write this one more time. Normal inverse, if I have x equals the sine of y, I can rewrite that as y equals sine inverse of x. Okay, so I can switch those two if I rewrite it as an inverse. So I'm going to rewrite this. Now this is going to be sine inverse of 2/3 is equal to pi over 6 times x minus 2. And now this is the tough part, because this is where my equation is going to split into 2 places. So I'm going to have 2 separate equations in a second. All right, so I'm going to go ahead and split that up. So the first one, I'm going to type in my calculator, sine inverse of 2/3. And again, check your mode, make sure you're in radians. And what I got from on my calculator was 0.7297. Let's see, so I'm going to round that to 0.730. If it's a general solution, it's plus 2 pi n. And that's going to be equal to the rest of that equation, which is pi over 6 times x minus 2. Now my second equation here, again, I have to think about this a little bit. So if I go back, this is sine inverse of a positive number. So the principal value for inverse sine of a positive number, it goes in the first quadrant. So the answer my calculator gave me is this right here. That is 0.730 radians. Again, remember, this is 1.57 radians. That's 3.14 radians. It's pi radians. So that's the answer it gave me. So what I need to think about here now is my second answer that the calculator didn't give me. That's going to be in the other quadrant where sine is positive. And that's the second quadrant. So I'm going to have the same reference angle in the second quadrant. So that reference angle right there is going to be the same. And the reference angle that I just found was 0.730. So in order to find that entire angle, I'm going to do it the same way I've always done. It's just a little bit different because I'm not using easier numbers. What you just have to realize is it's pi all the way around. So it's going to be pi minus 0.730. And that gives me my second answer. So in this case, my second answer is 2.412 plus 2 pi n. And then at this point, again, we're just going to solve this with basic algebra from this point. That's the hardest part right there, though. If you can get that second answer by looking at those quadrants, you're going to be fine. All right, so I'm going to continue to solve this left one first. So that first step I want to do is I want to multiply both sides by 6 over pi, so I can get those to go away. So I'm going to multiply all of that by 6 over pi. I'm going to do that in my calculator. And I get 1.394 plus 12n, okay, because I'm doing 6 over pi times 2 pi n over 1. So that's 12 pi n over pi. Those pi's cancel out. That's how I'm getting 12n. All right, and then this is going to be equal to just x minus 2 now. So my last step is simply going to be just to add that 2. I can only add 2 because I like terms to that 1.394. So that gives me 3.394 plus 12n. So that's the first part of my general solution. Okay, now I'm going to solve this other part for the rest of it. Again, multiply by 6 over pi and multiply by 6 over pi. I'm going to get a little bit of a different answer. But again, I'm going to do 2.412 times 6 over pi, and I'm going to do that in my calculator. And I got 4.607 plus 12n. And then my last step is just add 2. So this, let me highlight that. This is my general solution. Those are all of the places where I'll get a y value of 6. Okay, so let's say I want to find those first 3 x values. Again, I picked the smallest one, so the first one's going to be 3.394. Second one's going to be 6.607. And then the third one is going to be the smallest one plus 12. So that's 15.394. And the question we just worked out is actually number 2 on the homework. So that gives you a little bit of a head start. But that is it for evaluating sinusoids, and we're going to look a little bit more at that later this week.